Good morning, Northville students. I'm Sandra Brock from the Office of Instruction. We're so excited to have you today. We see classrooms are trickling in and our virtual students are continuing to join us, so we'll start in a couple minutes. Welcome to STEAM Fair 2021.
Sandra, if I can just jump in, we're getting a few questions about people wanting to turn their cameras on or unmute. We are actually in webinar mode, guys, so you won't be able to turn on your cameras or unmute. We ask if you do have questions and answers, you put them in Q&A, but we'll get into that a little bit later. But this is a little different than your usual Zoom meetings with your teachers. You're just going to be able to see our screen and our presenters.
So thank you, Ms. Holly. I think we're ready to roll by looking at the participant number. So welcome Northville 4th, 5th, and we also have some 3rd grade students who are in split classes here with us this morning at the Northville STEAM Fair. We are so excited to have you here today and have some phenomenal presentations from our community partners. And then you'll also be able to navigate the STEAM Fair website and see some awesome presentations from some of your classmates. So without further ado, we are going to get started. As Ms. Howley mentioned, we are in webinar mode. So we will go through some practices and protocols for you to ask questions. You will not be able to unmute yourself, but you will have an avenue for asking questions because we think that a lot of these presentations are going to excite you and you'll have great questions about science, math, and all things STEAM. So I'm going to turn it over to Ms. Mary Kay Gallagher, Superintendent of Northville Public Schools.
Good morning, everyone, and welcome to our STEAM Fair 2021, solving today's problems to open a world of possibilities for tomorrow. We have a wonderful day of learning, exploration, and opportunity ahead of us, a chance to stretch our minds, celebrate creativity, innovation, and the power of collaboration. I'd like to take a moment first to express heartfelt gratitude and appreciation to an incredible team of educators, sponsors, community and business partners who are making this opportunity possible. And first, hats off to Northville Educational Foundation, who has partnered together with us on our STEAM Fair effort each year, and our STEAM Fair committee members headed up by Dr. Sandra Brock, Teresa Osterhoff, and Krista Howley and Kate Mitchell of our Northville Educational Foundation. And of course, a wonderful group of teachers and student exhibitors whose work we will celebrate today as well. I'm pleased and we are grateful for our presenting sponsor and longtime Northville Public Schools partner, Community Financial Credit Union. In fact, we are celebrating our 30th year of partnership with Community Financial this year. And we also extend heartfelt gratitude and appreciation to many of our senior sponsors who have opened their doors to provide a window into their core work and problem solving, Cooper Standard, DTE, and ITC. And all of the sponsors who have contributed their treasure, their time, their talent to making this possible. It's a great day of learning ahead of us. And with that, I'll turn it over to Ms. Howley.
Good morning, everyone. I would just like to reiterate what Mrs. Gallagher mentioned, that we have a bunch of wonderful sponsors who make this possible for us today. Again, I'd like to thank our presenting sponsor, Community Financial. Sandra, can you forward the slide, please? And they have been our STEAM Fair sponsor for the last few years. And as Mary Kay mentioned, just a wonderful community partner to Northville Schools. Also, one more time, like to say thanks to our senior sponsors, Community Educational Credit Union, ITC, ZF, North America, Royal Truck and Trailer, First Merchants Bank, and DTE Green Power. I'd also like to thank our community partner, Cooper Standard, who along with ITC and DTE, a lot of initials today, have graciously given their time to present to us today. We'd like to thank all of our sponsors because without their support in helping make today's STEAM Fair, it wouldn't be possible. So thanks again to all of you. Mrs. Brock?
So Northville students, let's raise the roof for our awesome sponsors. Woohoo! So this is the agenda we'll be following today. Of course, we're starting with our welcome, and then we're so excited to have Cooper Standard, DTE, and ITC do live presentations for you, showing you how their industry works and helping you to learn more about math, science, and all things involved in STEAM. After that, you'll have some time facilitated by your teacher where you can go around the STEAM website and see just truly an abundance of presentations that cover everything from math to science to literacy and all things that really help us learn about making the earth a better place and what we can do to make the earth more sustainable. And I'm now going to turn it over to Ms. McLaughlin from Community Financial.
Thank you very much. Well, we are very excited to be a part of this process this year. We also have on the call with us, some of you students will recognize Mrs. Blaylock. Mrs. Blaylock, would you like to say hello to your students?
I would. Hi, everybody. I miss seeing you at your schools, but I'm looking forward to seeing you next year. And excellent job
Absolutely.
on your presentations. They are really amazing.
Yes, thank you. Yes, and then also we have with us Mrs. Kerwin, who well, I would also like to say hello to you guys this morning.
Hi, kids. Good morning. When I woke up this morning, I was so excited because I looked at my calendar and I saw this at 9:30 and I was pumped. So I'm excited to see what's going on today. Congratulations on all your hard work.
Yes, thank you. Well, we're very impressed and excited. As you can see, we have been busy reviewing the many wonderful projects, and this year there will be some awards. So keep checking in to see when those are posted. And the NEF and the Northville Public Schools Facebook pages will be announcing things as well as that evolves. But just congratulations to all of you, as Ms. Blaylock and Ms. Kerwin said. The projects have been amazing, and we have really appreciated all the work that you have done, the learning that has happened, and teachers, thank you to you as well. We understand what that means when we see the finished project. So thank you very much for that. Ms. Howley?
So Ms. Holly, I think you and I are going to both cover this slide, and students, this is really for you. We are in webinar mode, and we see so many familiar faces who are so excited to learn about STEAM. And as we work through some of the corporate presentations, you should see a Q&A tool where you're able to ask any questions that you may have. Ms. Holly and I will be your MCs today, so we'll be helping to make sure that the sponsors get those questions and that you get all the answers that you may be seeking. Ms. Holly, did you want to add anything?
I just want to remind you guys again, we are getting quite a few Q&As about why you're not being able to see yourself in video. We are in webinar mode, so you will not be able to see yourself. You're just going to be able to see our presentation. So please sit back and enjoy. And if you have any questions, please put those in your Q&A.
And without further ado, we are going to turn it over to Cooper Standard.
Hi, everyone. Thank you very much for having us here today. We're really excited to be part of your STEAM event. I'm Heather Christophus. I'm the HR manager here at our Leonard facility. And with me, I have Dave Malcolm, our plant manager, and Alex Peterson, our continuous improvement specialist. We're excited to share with you our Leonard plant, but first we're going to introduce Cooper Standard, who we are and what we do. We have over 25,000 employees that work for Cooper Standard, and we're located in 21 different countries. We make a variety of different car parts, which some of those you'll get to see manufactured today. But most importantly, we have really awesome employees who are great at their jobs and they like to help their communities. So we make really highly innovative car parts, and those help to improve comfort, safety, and vehicle performance. We make sealing products, fuel and brake lines, and fluid transfer systems. And you can see these outlined in the different colors on the truck. So now that you quickly learned about what we make, now we're going to talk about who we are. And Our employees and Cooper Standard as a whole, we love to make impact in our communities. Since 2013, we've contributed to $14 million through 18 different countries. We've had over 36,000 volunteer engagements, and we worked with over 125 different charities. And some of the opportunities we've had are to help build community parks, rebuild homes, and so much more. We also have a total safety culture at Cooper Standard. It's the most important job we have is to make sure that every person that comes to work goes home safe and sound. And so why is manufacturing cool? Why is automotive so cool? We have a ton of exciting career opportunities in manufacturing. There are a wide range of job types from production to product engineering and other supportive roles such as communications and purchasing. There are really countless career options across all different levels of education. You can see here on our career tree, this is just an idea of all the different opportunities that we have to offer. And Cooper Standard's really committed to helping ensure a really strong manufacturing base because that's essential to a strong economy. Automotive's also awesome because we get to be part of the next generation of mobility. Between electric and fully autonomous vehicles, automotive continues to innovate and evolve, and we get to be part of that every single day. We also get to travel the world. So with being a global manufacturing company that's located in 21 different countries, people also have the opportunity to travel and work with people from all over. So now that you know a little bit about what Cooper Standard does, who we are, and why manufacturing is a great career choice, our plant manager, Dave, is going to walk you through our Leonard facility in particular, and then we're going to see what we manufacture and get out on the plant floor.
Okay, thank you, Heather, and welcome everyone to Leonard, Cooper Standard facility. I'm Dave Malcolm. I'm the plant manager. Next slide, please. Okay, there's a picture of our facility in the upper left. We're about 28,000 square feet of manufacturing, so relatively small in the scheme of most Cooper plants, but very important nonetheless. We do make we have high-speed quick connector assembly equipment here and some injection molding machines. So we mold the parts that we assemble, so to speak. So it goes along the lines of what we call vertical integration. Next slide, please. And again, as Heather mentioned a bit ago, we're the plant that's very important in the moving of fluids in the vehicle. So we don't really deal in the other aspects of Cooper, but are strictly in fluid handling. Next slide. These are representations of the connectors that we make. So on the left side is a quick connector we call the Easy Lock, which is one of our newer innovative products. And on the right side is a Gen 3 connector. And in the middle there, you can see how our connector is utilized, right? That's a nylon or a plastic extruded tube that gets attached to our connector. Largely that happens in the Cooper facilities. And then the other end is what gets connected in the assembly plants. Next slide, please. And as we said, fluids in vehicles, many important functions. You can see there that everybody recognizes the gas pump, very common. Most of the connectors made in Leonard are actually what we'll call fuel connectors. So they move and handle gasoline. So very important, critical safety component on vehicles. Keeping the engine cool, right? That goes into your radiator system with water. So the vehicles typically today are transmissions are cooled with water, as well as engine components, as well as the all-important passenger compartment, right? In the third picture there, everybody's familiar with how to turn the air conditioner on and the heat. So that's water circulating through that system. Lastly, to the far right is up and coming, right? We're all hearing about these electric vehicles. There's many of them now being manufactured and on the road. not nearly the amount as the combustible engine, but we look very forward to that innovation coming in, and look to be a big part of that in the future. Next slide, please. Okay, a little bit getting into our plant. As I indicated earlier, we do mold the plastic components that we assemble. So we have 15 injection presses here that range in tonnage from 90 to 190. And the force that those tonnages apply, one way you want to think about it, it's about 50 times heavier than your car. So there's a tremendous amount of force that's used in molding of plastic. Next slide. And then we, again, assemble those pieces or components. We have 13 high-speed automations out on our floor. We're going to show a video here at the end of one of those machines in action. And one automation can make about 10 million parts is kind of the rule of thumb that we use pending the automation. So that's one connector that can be represented by every person in Michigan, if you will. After the parts are assembled, they're shipped to our customers. And again, we have many plants around the world actually assembling these connectors into fuel and water lines. And they go to pretty much all automakers globally. So some of the key ones in our area here in Michigan: Ford, GM, Stellantis used to be the Chrysler. And then, of course, we do supply Toyota, Honda here in the United States as well. Next slide. So our parts in action, right? Now that you've seen the connectors, this is kind of the interior of the connector, or the components that make it up. We do buy and insert a couple of O-rings to make that seal for us, which completes the connection, so to speak. And then some of the plastic components that all go into that black piece on the top is what we call a housing. So again, you'll see, get an idea of how that is assembled with the video. Next slide. Okay, and here's a representation. This is a Ford F-150 pickup. Everybody recognizes up in the upper left corner. And under the hood, it primarily is where our connectors are going. So you can see that we tried to highlight or circle the various connectors. There's one with a green retainer on it, you can see. And they're basically attached to lines either routing fuel or water under the hood. Next slide. And again, this is another vehicle made by Ford, the Explorer, that everyone can recognize, and the same type of thing. We have many lines under there. All three of these connectors that are circled are, again, our Easy Lock, which is routing water and glycol to keep the vehicle cool where it needs to be cooled. Next slide. Okay, now Alex, I believe, is online and going to, first of all, we'll talk about our safety culture, right? We do require the eye protection, foot protection, hearing protection, and using caution, right? Staying alert out on our production floor. Now we'll jump into the plant tour with Alex. Okay, this is what we call our automation 68, number 68, basically, and it is assembling the Easy Lock connector. So Alex is going to get a little closer to it over by the housing bowl where it all starts. So this, you can see the those things that he's having to walk around are component bowls, right? So they feed in one component at a time. And then it gets into that dial and gets inserted into a nest, we call it. And then we do have built-in checks or verification in the very next step. So the part will get inserted into our dial, and then it gets verified that it's there and in the right position. And then those components basically get assembled one by one. So if you remember the slide where we showed the O-ring, that's the first part put into the housing, and then followed by the spacer, and then an O-ring. Then Alex, if you want to move over to the top hat retainer station. Thank you, sir. So what's happening there is the last of the components are getting inserted, and then it's getting, again, checked. We do have some vision cameras on the machine that look for component placement and the right colors when color is necessary. Alex, if you want to move around to the retainer. You can see on the inline there a little bit where we're actually putting what we call a natural colored retainer into this particular connector. They do come in green and blue and red as well. Those colors are utilized by the car makers to indicate what connection point it's for. And then you can see we have some, most of this action on this dial is what we call mechanical servo motor driven action that's inserting the components. But you can see the use of a Epson robot right there as well. So we have an XYZ axis robot that are utilized in our assembly equipment as well. What's happening there is the parts being removed from the main assembly dial and being placed onto a test leg, we call it. So we do 100% leak test every connector that's made in this facility. Because again, if you remember the safety component, we can't have a leak getting out into a vehicle. So Alex, if you want to pan back to the test leg. Here we're actually doing the test, and you can see those testers up above are actually doing an air leak decay. So it'll flash from red, and there's a green indicator saying that they all passed. Okay, Alex, if you want to move to the unpack station. So we do have people utilizing, here's a screen that tells us what's going on with the machine and how many parts per hour we're making. And if there's anything wrong in the machine, it will flash on a video display like this. And again, this is where our operators are maintaining the machine, right? We have people that are keeping the components in the bowls full so the machine keeps running, as well as looking for what the machine is telling us. So again, Alex, if you want to go to the pack out. So this is the area here where, again, you can see the parts will come off the leak tester and be fed into a shipping container, basically. So we went from, on this particular connector, a total of 5 different components becoming one connector going into the box that will get shipped to ultimately to the customer, to the car factory. That really completes our tour here at Cooper Standard. So we appreciate the time and thank you all.
Wonderful, thank you. Students, please give Cooper Standard a Northville round of applause. And while you're doing that, we're going to move on to some fantastic questions that students have posed. So the first question is, and I believe this was touched on, is do you help make electric cars, and maybe a little bit more detail on how you do that?
Yes, we're obviously that's what we'll term an emerging market. So we're very involved. Some of the traditional automakers, as well as some of the people that are out there doing it right now, the Teslas of the world. So from a fuel handling or a electric vehicle standpoint, we're in the fluid side of it. So we're looking at, again, those batteries require significant water to keep cool. So there's actually more connector content on an electrical vehicle than there is traditional vehicle.
Wonderful. A great question from Akil. What is your favorite thing about your job at Cooper Standard?
Well, that would come down to the people, right? Cooper Standard's a very, very positive environment with a great culture.
And Daniel's asking, how long has Cooper Standard been around?
Cooper Standard, as we're designed today, or it's a company is kind of a conglomeration of previous companies. So 2006, was the year that the current CSA came into play.
And-
It
Oh, go
starts,
ahead.
yeah, some of the other companies started as early back as 1960.
Great. Sujana wants to know if you all make motorcycle parts also.
Yes, we do. We, in fact, out of this plant, we make connectors that go on Polaris vehicles as well as some Honda motorcycles.
And Mahib wants to know if every car has a connector.
Yeah, traditionally every car has several connectors. Some going back to some of those pictures that you saw on the F-150, the water cooling alone, we have 10 different connectors on there just for the water cooling. So there's many, many connectors on vehicles.
And the last question that I see, and Miss Holly, let me know if I missed anything, is who founded Cooper Standard?
Who founded Cooper Standard? I'm gonna have to
We'll
defer.
follow up on that one.
Not sure I'm gonna know that answer.
The other
Ms. Holly,
question,
oh,
we
go
have
ahead.
several questions just in terms of the kind of parts that you actually make, and if you make them for all types of cars across all manufacturers or specific ones.
Yeah, there's nothing specific about it. We do work with pretty much all automakers and always have. The prior question I'm being told was Cooper Tire is actually the founder of it, right? It wasn't necessarily an individual, but a corporation.
So basically, manufacturers can't make their cars without the kind of parts that Cooper Standard makes. Is that correct?
That's absolutely correct. I won't say that we're the only maker of connectors, but we are on a lot of vehicles out there. And yes, we like to think of ourselves as certainly integral in the making of a car.
We also have a few people who are saying that they remembered that your headquarters is also in Northville and that it's right near their homes.
That's right.
And that maybe
right.
someday they'd like to work for you.
Absolutely. We are always hiring and looking for talented engineers, operators, basically every position imaginable. We have a need.
Wonderful. Well, thank you, Cooper Standard, for being such wonderful partners and for being here today. There were lots of shout outs in the Q&A about how fascinated the students were with your presentation. So thank you so much.
Good. Thank you.
So our next presentation is going to be from DTE.
Good morning, everybody. How is everyone? Just waiting for the presentation to share. There it is. All right. Thank you so much for having us today. We're excited to be part of the STEAM Fair, and we're hoping to give you some good information about DTE, the environment, and the work that we are doing, specifically in the renewable energy space with wind and solar here in Michigan. And we're going to give you a little bit of details, but one challenge I have for you throughout today's presentation is to really think how science, technology, engineering, art, and mathematics really are a holistic view of what we do here at DTE to make sure that we can provide clean energy for you, not only at home, at your school, and in your communities. So my name is Mr. Newman, and I work very closely with my friend, Mr. Gorman. Mr. Gorman, if you could say a quick hi.
Morning, everybody. My name is Mr. Gorman. Happy to be here.
Yeah, so we really want to just talk about renewable energy and really dig into how it works for everyone here. And we're looking forward to the questions at the end. So Chris, if you go to the next slide, please. So just to start with an overview, who is DTE? DTE is the state's largest utility. The electric side of our company, which we'll be focusing mostly on today, serves 2.2 million customers in Southeast Michigan. Our gas side of the company serves 1.3 million customers. We have nearly 11,000 employees, and we are proud to say that our foundation is one of the state's largest foundations. So Michigan, it's very important to us to invest here in our backyard. We are Michigan's renewable energy leader. we are the largest producer and investor in renewable energy in the state. It has helped actually sustain over 4,000 jobs since 2009, and DTE has invested over $3 billion in renewable energy so far, and we will invest another $2 billion in the next 3 years. So we're just going to pause here for a second for a quick knowledge check. How many jobs have been created by DTE's investment in renewable energy? Take a few minutes in the classroom, think amongst yourselves, and maybe talk amongst your classmates and answer.
And if you want to place your answer, A, B, or C, in the Q&A, we'll be taking a peek at that.
All right, it is actually A. So everyone that guessed A, great job. And there will be more knowledge checks coming. So that's our way to make sure that you are still with us here. Next slide, please. All right, so I just want to touch on real quick, DTE is investing so much time, energy, money into renewable energy. Well, why are we doing that? The main reason is because of carbon emissions. Carbon emissions is essentially what occurs when we have heavy manufacturing or coal power plants. It's a form of air pollution, and it actually is one of the leading causes of global warming. So we want to reduce as many carbon emissions as possible. And one way we can do that is to build more renewable energy and use less coal. So over time, DTE's goal is to be net zero. And that means have no carbon emissions. By 2 years from now, we're actually going to be 32% healthier than where we were a few years back. And all the way up by 2050, it seems like a long ways away, but we are actually going to have no carbon emissions by that year. So we're very excited to share that long-term goal with everyone. Next slide, please. So you may wonder, what is or where are the renewable energy assets for DTE? You can see the map on your screen. We actually have 15 wind projects. These are massive wind parks here. And we actually have 3 new wind projects coming online here in the next couple days. Chris, Mr. Gorman is going to take us flying over one of the turbines. It's really cool video. And we have 31 solar projects. There's actually many around the Northville area. So if you ever see any solar panels in your area, that's more than likely DTE producing clean energy to bring to your home. So another knowledge check. How many solar parks does DTE have? And feel free to add your answer right into the Q&A.
All right, we're seeing lots of answer C's.
Very good. It is C. We have 31 solar parks, and we're proud to say that we are going to continue to build more and more solar so that we can continue to have a greater positive impact on the environment here in Michigan. All right, Mr. Gorman, if you could take over here and talk a little bit about the anatomy of a wind turbine.
Okay, thanks, Mr. Newman. Good morning, everybody. So as we mentioned, one of the main ways that we support DTE's renewable energy goals is through wind energy. Now, you may have seen some of these wind turbines up near the midsection of the state of Michigan. These are large, almost fan-like structures that use the wind that's blowing to spin and create energy through a generator that's actually placed way up high in what's called the nacelle. Now, if you look at the total diagram of this wind turbine, you'll see it's made of 4 major components. What we call a rotor, which are the 3 blades that are hooked together and spin, the nacelle that I mentioned earlier, which houses the generator that actually makes electricity, which is on top of tower sections, which make it go way high up in the sky. And then that's all on top of a foundation, which is made of hundreds of tons of concrete to keep the wind turbine locked into the ground. Now, if you look on this diagram, you can see an outline of the Statue of Liberty. Now, think how tall the Statue of Liberty is. It's just over 300 feet tall. So our wind turbines are almost 500 feet tall. which is significant because the wind is actually blowing much faster up in the sky. So it allows us to be much more efficient the larger the turbines are. Each turbine can produce enough electricity to power more than 700 homes just on its own. So you may ask yourself, well, how does this turbine actually generate energy? So we're going to watch a short video that can go through and show and demonstrate just how we create electricity that can get to your home from one of these turbines.
As turbines' blades rotate, they capture the wind's energy. Those rotating blades activate gears inside the turbine, spinning faster and faster, which ultimately generates electricity. The amount of energy produced depends on the size of the turbine and the wind speed through the rotor.
Okay, that was an exciting look at a wind turbine, but you may ask yourself, do people actually have to service these big items? Do they go on top of them? Well, let's take a look at what it looks like from the top of a wind turbine.
Technicians work both inside and outside of the turbine and can carry tools and equipment that weigh more than 25 pounds. Let's get a view from the top of the nacelle, something few people will ever get to see. The instrumentation you're seeing now is the anemometer and the wind vane. Remember what these parts do? They're sending messages to the controller about the speed and direction of the wind. If you're afraid of heights, a career as a wind technician probably isn't for you. But if you can handle being strapped in 300 feet off the ground, you'd get to experience the most incredible views like this sunrise all the time.
Okay, very exciting to see how a wind turbine actually looks out in the field. So another knowledge check for today. Answer this question amongst yourselves and in your classrooms. The amount of energy generated from a wind turbine depends on the turbine size and wind speed. Is that true or is that false?
So we see lots of trues being posted.
Very good, very good. As we mentioned in the video, the bigger the turbine is and the taller it can get up into the sky, the more energy it is able to generate. So another way that DTE Energy generates renewable electricity is not only through wind, but also
Unlike
through
wind
solar.
and other energy sources.
One moment. So another way that DTE Energy generates electricity is through solar power, which is actually consisted of many different solar modules strung up together to capture the energy from the sun. Now, if you consider a wind turbine, it's very tall. You can think of a solar park as very long and spread out over many different acres. This is actually our Lapeer solar facility up in mid-Michigan. It spans over 250 acres in size. And these solar panels are enough to generate power for as much as 9,000 homes for an entire year. Now, DTE's plan, as Mr. Newman pointed out, is to generate or is to decrease our carbon emissions ultimately to zero. So our plan is to expand our solar fleet by as much as 6 times in the next 3 years and as much as 10 times in the next 10 years. So we may see these panels sitting on the ground and they don't actually spin like a wind turbine does. So how do they generate electricity? Let's watch a short video to go through that.
Unlike wind and other energy sources, solar energy doesn't require a generator to create electrical energy. Instead, solar energy relies on a reaction that happens inside the solar panels. Let me break it down for you. Believe it or not, the part of the solar panel where electricity is generated is mostly made of sand that gets converted to silicon. Solar panels are comprised of hundreds of photovoltaic cells, meaning they're capable of producing an electrical current. When the sun's rays shine down on the panel silicon, they cause the electrons inside the silicon to get excited and break their orbit. This movement of electrons is completely random. So in order for the electrons to flow together, they need a path to travel on, like on a wire. Now, connecting a wire to metal plates does just that. It creates a pathway for the electrons to flow, resulting in DC, or direct current. Okay, that's how a solar panel generates electrical energy. But where does this current go? The DC electricity from the solar cells is captured and fed to an inverter, where it's converted to AC, or alternating current, so it can efficiently travel over long distances. This energy travels across high voltage power lines to a step-down transformer, where it's converted to a lower and safer level of power before traveling across power lines to your home. The electrical energy generated from solar parks enters the power grid, just like everything else, and joins the energy mix with other sources, like wind and natural gas.
All right, great. DTE is very excited to be able to produce solar power and create more so we can provide clean electricity to your homes as well as the businesses that we live in. Okay, one more knowledge check. The part of the solar panel where electricity is generated is mostly made of metal, sand, or gravel. Put your answers in the chat or discuss amongst yourselves.
Lots of people saying B, sand.
B.
Very good, very good. Mostly the panels are made of sand. So DTE is extremely excited to be a part of our future and actually a leader in the future of renewable generation for the state of Michigan. And as you can see here, there are many different types of jobs that are required at DTE Energy in order to meet our goals. These can be engineers, accountants, technicians, and even folks like scientists are extremely helpful in facilitating the meeting of our renewable energy goals. And DTE is just very excited to be able to be a part of this. And if something that you're interested in is sustainable energy, you might consider working at DTE in the future. Thank you, everybody, for having our presentation today and following along. We're very excited to take any of the questions that you might have from the chat in your classroom.
All right, Northville students, let's give a big shout out to DTE for another fantastic presentation. And the students have a lot of great questions for you. So the first question is from Everett and actually a group of students. What does DTE stand for?
So
That's always a great question.
Yeah,
DTE is actually an abbreviation for what used to be Detroit Edison. DTE has been around since 1903, and we changed our name to DTE from Detroit Edison back in about, I believe it was 1996.
I think a lot of the staff probably remember Detroit Edison.
Oh yeah.
Okay, where is DTE headquartered?
Great question. We are actually headquartered in downtown Detroit.
We also have some questions about the turbines. How many wind turbines have you made?
DTE has about 1,000 wind turbines spread throughout the state of Michigan, and that number is actually growing every year here. We've got more farms that are coming online every year.
And Adam is asking, why are the wind turbines so tall?
Great question. So the turbines are so tall because the wind actually blows faster up in the sky, up higher in the sky. So in order for them to be the most efficient, we have to build them very big so they can capture more energy for us.
Miss E's class wants to know, how many rotations does a turbine make in 1 minute?
That's a great question. So that depends on how fast the wind goes. And there's also a safety component that's added into that. A turbine blade can spin as few as 0 rotations a minute. They can actually be completely stopped. And the maximum is generally about 30 rotations per minute. Any faster than that, and things start to go a little bit too fast for us, and we actually have mechanical mechanisms that can control how fast it goes. And if things start to get too quick, we actually slow it down so it doesn't get out of control.
Ms. Haynes's class is asking, what type of metal is used for the turbines?
That's a great question. So I imagine there's different components that are consistent of iron, but mostly I would think they're made out of aluminum. There have been experiments with different types of turbines that are made out of lighter technologies like carbon fiber, but those tend to be a little bit more expensive.
And there's another great question. How did the wind turbine get its name?
That's a great question. I would say that the first component, wind, that comes from the fact that it is capturing the wind energy. And turbine is actually a term that's used in multiple different applications. A turbine can be essentially something that spins, and a turbine can be spun by coal-fired steam, which is how it's traditionally been done. But the same technology, an electric generator that is spun, it's actually used in it's the same type that's used in a turbine and also in a traditional power plant. So turbine is essentially something that spins and generates power. So if you put wind and turbine together, it essentially means wind power.
So we have numerous students asking, what happens if there's a day where it's not very windy? Does that have any implications for the turbine?
It does, it does. So when there's no wind, the turbines actually won't spin, and that means there's no power that's generated. And that's one of the challenges that DTE faces with wind turbines. If the wind's not spinning, we're not able to use them to generate power. So we have to pull it from other sources, for example, solar power, or some of our natural gas facilities.
And Evie's asking if there's a way to make a small model of a turbine at home.
There is. There are all kinds of different small experiments you can use. You can make them out of cardboard. You can make them out of popsicle sticks. You can use all kinds of small experiments to demonstrate how these things work on a much smaller scale. So maybe that's an experiment you can try out with your class and you ask your teacher.
Ms. Holly, did we miss any questions?
There's a whole bunch of questions about which generates more power, maybe wind versus solar.
So that's a great question. They generate power in different ways. So one might not necessarily generate more than the other. And a really key fact in answering that question is how windy is it or how sunny is it out? If it's very windy, but there's a lot of clouds overhead, the wind turbines will generate much more power. But if the wind isn't blowing, but it's a beautiful sunny day outside, the solar will generate much, much more. But DTE has much more wind than we do solar right now. And that's going to be changing in the next couple of years as we build more and more solar panels.
Great. There are more questions, but I think we might need to move on right now, and maybe we can try to get these answered later.
Great. Thank you.
So again, a thank you to DTE for always being a partner of Northville Public Schools, and thank you for presenting today. And thank you to the students who had some wonderful questions for DTE. And we're now going to move into our next presentation from ITC.
Good morning. I will try to share my screen. Good morning, everyone. I'm Miss Adele with ITC, and you have probably heard the word ITC, and it's been a while since I've been in 5th grade. So I thought maybe we'll start with a little quiz. So what is ITC? Do you think we're a sports park? So type in A, if we think we're a sports park, or B, if we're a snack company, or C, an electric transmission company. Let's have some fun. Okay, let me look at the chat.
So mostly C.
Yeah, if you answered C, you are absolutely correct. And yeah, it is true. There is a sports park in Northville. It's actually City of Novi, but it is Northville ITC Sports Park. It's a park that we helped build with the City of Novi, but we are an electric transmission company. So if you answered C, you are correct. And, trying to move to the next one. And I'm with ITC's local government and community affairs. I'm very excited to participate. It's my first time being a part of the Northville Public Schools STEAM Fair. What I do is that I serve as a contact for ITC with your local government and community. You may be wondering, what is local government? Well, they're those individuals that have been elected or appointed to ensure that your community is safe, clean, and beautiful. So if you live in Northville Township, it would be your township board, or if you're in the city of Northville, it would be the city council, and they make laws and decisions that affect the roads, that affect safety, and schools, parks, and so forth. So it is a really fun job. But then on the ITC standpoint, you may be wondering, we help deliver electricity, but how does that work? So as you heard DTE earlier, they covered how electricity is generated, but then after it's generated, it has to be delivered to your home. And I'm going to show you this video, and we'll also pause a little bit to answer some questions. All righty, here we go.
You use energy every day, probably in many ways you don't even think about. It's there every time you turn on your computer, play video games, or turn on a light. It's also used to charge cell phones, power your refrigerator, heat water for a shower, and keep your home warm or cool. Have you ever wondered how energy gets to your home? What happens before you flip that light switch or turn on that video game that allows you to have energy whenever you want it? All the poles and wires you see along the streets and in front of your house help move the electricity to your home. Those wires connect your home to the power plants. Electricity has to travel a long way to get to your house. In fact, the power plant where your electricity is made might be hundreds of miles away. And the natural gas that heats your home works in a similar way. The gas meter and line that connects your home to natural gas travels through pipelines underground to a city gate and then continues on long distances to a refinery where it is made. But let's start at the very beginning. Many years ago, plant life and other organic life died and has existed underground for thousands of years. As the earth changed, constant pressure and heat turned this material into what we call fossil fuels, like oil, natural gas, and coal. After the fossil fuels are taken from the ground, some is burned in power plants to boil water and make steam that causes giant turbines to turn and generate electricity. Because it takes so many years to make these fossil fuels, there's a limited supply. We call these non-renewable resources, and they will eventually run out. Think of your birthday. It's a fun day, and you enjoy it while it lasts. But once it's over, that's it. You'll never have that birthday again. We enjoy using fossil fuels, but once they're gone, the party's over, and we'll have to find new energy resources. Recently, we have started to harness power from renewable energy sources like the sun and the wind. These are renewable because they will not run out. We can continue to use them, and Mother Nature will just keep making more. But what do you do when the sun doesn't shine or the wind doesn't blow? You probably still want to play your video game or turn on the lights, right? It's important for us to have fossil fuels like coal and natural gas so that you can have energy when you need it. But because there is a limited supply, it's really important to use energy wisely and not waste it so it will last a long time. Now that energy is created, it has to get to your house. The newly created electricity is sent through transformers to increase the voltage to push the power over long distances. Think of this high voltage like a really tall roller coaster.
And I just wanted to pause for a second. So this is exactly ITC's part. So we're the high voltage, and that's our equipment. So we have these big transformers. So after electricity gets to that high voltage, then it's transferred through the big towers that you see on the sides of the highway and the wires.
The car climbs up the big hills on the roller coaster to give you enough energy to travel a long distance. By pushing the voltage higher, it can move the electricity greater distances. The electricity travels through transmission lines like these.
And these are exactly ITC's transmission lines. So these are the high voltage. And anything in the state of Michigan, anything that's 100,000 volts and above, it's considered high voltage. And when you have a physics class, you'll know more about voltage.
They stretch across the country for miles. And as the electricity nears your home, it enters a place like this. It's called a substation. It lowers the voltage of the electricity. Think about that roller coaster again. It's traveling pretty fast after going up that big hill. So now you have to start putting on the brakes and slow it down so you can get off the ride. The substation is putting the brakes on the high voltage so it can be sent safely to smaller distribution power lines on the streets and underground in your neighborhood to deliver electricity to your home. The electricity is almost to your home, but it has one more stop. It filters through another transformer on a pole or on the ground near your house to make sure the voltage is safe enough to enter your home. Once inside, it's available for you to use anytime you want it by just flipping on a switch or plugging into an outlet.
All right, and we'll stop here. So that's what ITC does. We're the blue area right here. So we own, maintain, and operate the high voltage transmission towers and lines. And then we connect with, for example, DTE, that's one of our partners. The high voltage then gets reduced to lower voltage, and then it's ready to be distributed to your homes. So if you look at the 8 steps that go when you flip on that switch, ITC is step 2, 3, and 4. And a little bit more about ITC. We're in 7 states in the Midwest. If you look at our USA map, we're here, we're all these, we're the blue and the green, and we're headquartered in Novi on 12 and M5. You've probably seen a big building that's brown and gold. That's our ITC headquarters. We were formed in 2003, and since our inception, we have invested over $7 billion in electricity. And in terms of workers, we have 500 office workers and over 1,000 what we call field workers. So this is a typical day of one of our field workers. Sometimes they get to climb in these high towers, and some of these towers can be up to over 100 feet tall. And sometimes they get to ride in a helicopter. So that's a fun job to just inspect our equipment, make sure everything is working well. Sometimes there could be a down wire, so that gets replaced. And also we make sure that we're inspecting our electric equipment on a regular basis, not only when there's an issue. And then some of our office workers get to watch TV all day. I'm kidding. We do have these big screens in what is called our operations control room. So these workers are working on a 24/7 basis in different rounds, and they monitor our electric grid. As you can see, these are huge flat screen TVs, and kind of similar to the subway, kind of similar to our roadways, highway system. That's how electricity is. Sometimes you see collisions in a highway, so we want to make sure that all the electrons are flowing where they're supposed to, and there are no issues. And if there are issues in the system, it will send some alarms. So then we're able to dispatch or send somebody out in the field and fix that problem. We also have workers who have other functions. For example, in my function, previously, I was helping some of the OCR folks with reporting, making sure everything's working well. But now I like to do more of the community aspect. And in terms of STEM education, I know we have participated in the Northville STEAM Fair previously, and we also host our Bring Your Child to Work Day. Unfortunately, because of COVID, we were unable to do it last year or this year. I know this year was a couple of weeks ago. But in the past, we've had our mascot, Victor, the high tower, who comes in and teaches children about electricity. For example, here they're doing fun games about static electricity. And then here we went to summer camp and we were teaching some young women about electricity. And they also got to decorate their own lamps. And then here, there were other activities that we're doing for the younger kids. So for the Bring Your Child to Work Day, we have anywhere, I believe it's from 7 years old and above up to high school. And we have different activities separated by age groups. And then in terms of community, we really love the communities that we serve. And we serve all of the Lower Peninsula in Michigan. So we are involved with various charities. For example, here, we were helping the Red Wings Foundation with a parade company. And also, I believe here we did an event that was for one of the animal shelters and the food banks. We also like to help build trails in communities so that you and your parents can go for walks and ride your bikes. So there's a lot that goes in. ITC really cares about the communities that we serve. And this in a nutshell is my job. Does anyone have any questions?
So I think we have some great questions in the Q&A, and while we get to that, let's give a round of applause to ITC for a phenomenal presentation. They're our last presenter of the day. Our first question comes from Ms. Kale's class at Moraine. How fast does electricity travel?
Wow, that's a really good question. And I have a secret. I'm actually not an engineer, so I have no idea. But if anybody from DTE knows that, feel free to answer.
We can follow up on that one too.
Yeah, we can follow up. Absolutely.
How does ITC work with local governments?
Yes, that's a very good question. So what we do is that before we build a tower or a power line, we want to talk to your community. I want to make sure that we are not impacting you in a negative way. And also we work to make sure that we are abiding by what is called ordinances. So those ordinances are the laws that your local government has put in place to make sure that your community is safe. So anytime that we're building a power line, we also want to make sure that we are not impacting traffic, for example. And also for safety always comes first for us, for ITC. We're always rated top tier in our industry. So that is number one for us. So we want to make sure that we're building these power lines and we're building them in the right place, and also that they're close to your homes as well. So we're able for you to have safe and reliable power. So we will talk to your township, for example. Sometimes we have to go in front of city council to ask for approvals, and they have questions, and we provide all the drawings, all the designs, and sometimes they could come back to us and say, well, I don't think you should build this line here. Can you move it there? And we say, yeah, sure. We'll work with our team and see what we can do. So those are the types of things that we do. We also like to inform them on a regular basis, even if we're not building a new line, if we're rebuilding an existing line, we make sure we let them know when that will happen and the process. And also, I sometimes serve as the contact person. If they have any questions, we usually get those answers within 24 hours.
Great. Ms. Cameron's class is asking, what does ITC stand for?
Yeah, that's a really good question. So when we were formed in 2003, ITC meant International Transmission Company, and then we went through a few rebrandings. So now ITC doesn't really stand for anything, but back in the day it was International Transmission Company, kind of like what DTE said. So it's kind of similar story.
And lots of comments that they love the big screen and that it looks like NASA.
It truly does, and pictures do not do it justice. However, we're big on safety and security. We do not allow visitors. You have to go through the system, and even if you're able to, bring your child to work day, we actually allowed students to be able to see it, but they have to go on an observation room and they cannot take pictures because it impacts the national grid. So that's very important.
Great. Ms. Holly, do you see any other questions for ITC?
Mrs. Witter's class was asking how much energy do people use in a day? I don't know if you have that answer, or if maybe DTE does. How much energy is used in Michigan in a day?
Yeah, that's a really good question. And for us, we're not, so when you get your bill, your electric bill, you're not going to see ITC's name, but 3% of the electric bill goes to ITC. However, we don't have the data in terms of the residents. That's more DTE because they're the distribution company. But what we do at ITC, we do look at the peaks. It's called the peak. So how much load we got in a month. So we measure that on an hourly basis for the entire month. And that was my previous job. I don't really remember. I thought in the tens of thousands of megawatts per hour.
And I think it really helps us to understand the infrastructure and how DTE and ITC work together to bring energy to our homes and businesses and schools.
Oh, absolutely. There's a lot that goes on behind the scenes. You think you're, flipping the switch, but you don't know that there's a lot of companies that are working together and a lot of pieces. And we really appreciate the partnership with various companies.
The only other question maybe is, does ITC just work in Michigan, or are they in other states?
Yeah, that's a really good question. We're in 7 states in the Midwest. We're in Michigan, we're in Iowa, Kansas, I believe parts of Minnesota, we're in Oklahoma. So it's mostly the Midwest. And as of 2016, our parent company is Fortis, and they're a Canadian-based company. They're also in the Caribbean. So they're also in Arizona. So they're in a lot more states than us.
Wonderful. Well, thank you to ICT for being here today. We're thrilled to have you as our partner, and thank you for your wonderful presentation.
Thank you for having me.
So again, a large shout out and big thank you to all of our presenters. We were just thrilled to have you here today and allowing staff and students to learn more do and the connection to STEAM. The next step on the STEAM Fair process would be really to allow some time for students to navigate the STEAM website. So staff, that should be in the documentation that was sent this morning. If you need it, certainly reach out to Ms. Holly or myself, but there are just a large amount of student creative projects that cover everything from physical life to all types of sciences and engineering. So we hope that you enjoy that part of the program. And then just a friendly reminder that the website will be up and running tonight as well into next week. So if you want to spend time this weekend looking at projects with your friends and your family, the opportunity will be there to do so. Ms. Holly, did you want to add anything before we bid adieu?
Nope, just a reminder that we will have awards posted at some time later this week or next. So please keep an eye out on the website and of course on the Facebook pages as to when those are going to be announced.
And thank you to staff and parents at home who were able to get their students to the virtual STEAM Fair. And we were just excited to have you here today. So enjoy the rest of your week and take care.
Quick thing for the panelists.